Sure. So I don't have a mic?
No, but you can stand at the podium.
All right, if you find it, just bring it up.
Thanks, Mike. Thanks, Mike. Next, I'm happy to introduce Patrick Wendell. Patrick has been the release manager of Spark for the last many releases. He's one of the most active developers. I think if you look on GitHub, his name is second to Matei's for commits to the project. And he will be talking about the future of Apache Spark.
Thanks very much, Andy, for that intro. Thanks, Mike. That was a great talk and a tough act to follow. I'm curious, any way we can get rid of the sidebars here on the screen? Just seems like there's something next to it. I'm assuming you guys are working on that, and I'll just get started anyways, and we'll see if it goes away. Yeah, so just give me 1 second here. All right, great work. Also, yeah, Andy, if you find the wireless mic, I can throw it on during the talk, but I'm fine to talk from behind the podium. Yeah, so hi, everyone. Just to introduce myself, as Andy said, I'm Patrick Wendell. I am very active committer on Spark. I work at Databricks. Mostly what I've been focused on in the last few months is just formalizing the way we do Spark releases and kind of getting the community in a good place to do good release management for our constituents. So I just want to start by kind of explaining, here's what a week of Spark development looks like. Oh, that's fine, I'll just use this. Because as Matei mentioned in his talk yesterday, the project is very active. So a week of Spark development, this is a very unscientific stat count that I did immediately before this talk. We have about 500 times someone will update a patch that's currently being reviewed. We have 200 updates to our issue tracker, 140 emails on a user list, and something like 80 patches will get merged. So one kind of cute insight from this that I didn't think about was that it means the average person has to update their patch 6 times before it's good enough to be merged into Spark, if you divide the first number by the last number. But yeah, so we do kind of thorough code reviews. So what this talk is about is the future of Spark. So it's clearly growing quickly. You see there's a lot of activity. What are we looking at in the project in the next 6 to 12 months? And this is kind of a bottom-up perspective from developers of Spark. There's kind of two parts to this as far as I am concerned. One is how are we going to do releases? What's the relationship we're going to have with our users, with the developers that build on top of us? The other is kind of what is the technical roadmap? What features are we going to add in Spark, and what kind of cool, shiny new toys are we going to give to you? So I'm going to start by just reiterating what the goal of the project is. And this is what we go back to whenever we're making major strategic decisions about what we do in Spark. The goal of the project is pretty simple. We want to empower data scientists and engineers and give them good tools to get the things that they need to get done quickly and done without a lot of work. But that compiles down to some more specific kind of objectives. So what we really focus a lot on is having good expressive APIs. Ultimately, if you want to build a platform, you need to have really well-defined, powerful, stable, and supported APIs. And so we think a lot about the design of APIs in Spark, and that's kind of what we think about when we look at our roadmap. Another big thing is having a unified runtime. So we're going to provide good APIs, give you powerful tools. Well, we want this to work well in a bunch of different environments, and that's another a kind of key goal of the project. And the last thing, which I'll talk about a lot, is having really, really good standard libraries. If you look, most people don't describe their problem in terms of, I want to move some data from this node to that node. They have higher level descriptions of their problems in a domain-specific way. And so a big goal in Spark to empower developers is just give them powerful libraries out of the box. So first, I'm going to talk about just higher level trends in the next coming 6 to 12 months. And then I'm going to go into the really kind of technical roadmap. A big thing we're doing in Spark now is focusing on API stability. So in the most recent release of Spark, we made a very clear marking of what are our public APIs, and even maybe more important, what are APIs we consider experimental or things that you might expect to change if you're going to build on top of them. And this is super important for any platform, because it means that applications you write against our public APIs are guaranteed to work for all future versions of Spark. we actually have invested a ton of effort in tooling in the Spark community to have like really a first-class support for API stability. If someone tries to submit a patch that breaks an API, when you have a very active project with hundreds of people contributing to it, it's really easy for someone to accidentally change something in a way that breaks an API. We automatically detect that case and fail their patch, so it won't get merged. And this is something, as far as I'm aware, we're like the only project that has the set of capabilities that we do, because we had to invent a bunch of kind of homemade infrastructure to do this. So on top of stable APIs, another kind of trend in the project is having a really dependable release cadence. And this is something that in a fast-moving project is absolutely necessary to be able to provide stable and sort of comprehensible releases to users. So what we've done here is we have a 3-month release cycle where every 3 months we do a new minor release of Spark with new features. And we don't hold those releases for features. So you know that every 3 months you're getting a new release, and if someone's feature slips, it bumps into the next release. But maybe even more important is we're continuing to do very active maintenance releases on top of older versions of Spark. So this means you can go and get a maintenance release if you're willing to take a slightly older version of Spark but want more stability. We're going to give that to developers. And that actually comes at a fairly high cost to us because we're maintaining old branches. But we do it because we want to basically make developers happy. I mean, it's something that essentially we do more work and it's better for the developers. And that's the trade-off we're happy to make. So those are kind of the high-level developer relationship things going on in the project, but I think kind of the exciting stuff is really the technology. So for those of you who haven't kind of gotten the full stack diagram at any point during this conference, what Spark is kind of two things. It's a core runtime, and that runtime is portable across different cluster managers like Mesos, Yarn, et cetera, and also interoperates with many data sources. But the kind of most exciting newer activity in Spark is in these higher level libraries. And there's 4 of them I'll just mention quickly. Spark SQL, which is a library for writing sort of SQL expressions and having those compiled onto Spark. A machine learning library, a graph processing library, and Spark Streaming, which is a sort of real-time continuous processing engine. And the sort of mere idea that you could take one data model and computation model, which is SparkR, and write these very different programming paradigms on top of them was not something that was obvious that you could do that like 2 years ago. So this is kind of one of the coolest things about Spark in terms of what the project looks like. But the future of Spark looks differently for these two things. So for SparkR, it's a fairly mature API. At this point, we're not making really major changes to the API, and most of what's going on is about optimization and better integration with other systems. In the newer libraries, those are sort of rapidly adding features and adding new APIs. So these are kind of slightly different things. So if you want to know what the future of Spark is, well, really, the future of Spark is the libraries. That's how you should think about kind of what the community is investing in and where most of the innovation is happening these days. And I work on mostly SparkR, so this is really a statement coming from me. So why do we care about these? Well, for any runtime, it's absolutely critical to the success of the runtime that you have good standard libraries on top of it. If you look at other things like the Java virtual machine or like the Python interpreter, in many cases, the whole reason why people even use these things in the first place is because they have excellent and great coverage of standard libraries. In some cases, people will use even very clunky tools, like Perl is one example, because the standard library is just so powerful and has so many useful things in it that they're willing to even accept like a really clunky runtime. So we like to think the core is actually pretty good in Spark, but we also want to provide these libraries. And the way that we approach these in Spark is very different than in past projects like the Hadoop ecosystem. So we actually package and develop and distribute these all with Spark. So they are released in tandem with Spark. And I think that's a pretty important point to make. The reason is that we think really carefully about the way that we express things like the data model and these other kind of shared concepts in these libraries so that it's consistent and it's consistent and works well with the core Spark API. In other communities where you have many different projects that are fragmented, you tend to arrive at these like semantic gaps and other problems in the way that they interoperate with each other. But we like test and tightly integrate them together. Another thing I'll mention as kind of a little bit of a brag, but I do think that we have, in many cases, like the best people in the world working on these domain-specific libraries, people who are really, really experts in the fields. And it results in a super interesting project because you have really, really smart people across many different fields, machine learning, databases, and so forth, interacting and trying to kind of build a system together, which is a really neat experience. So I'll talk first about Spark SQL. I don't have time today, unfortunately, to talk about all the cool stuff we're doing. There's just way too much of it, and this is a short talk. But I've kind of chosen some things that I think might be particularly interesting for the community. So Spark SQL is the fastest growing component inside of Spark. Many of you probably saw Michael's talk, or I've seen other talks about it today. What it provides you is the support for expressing, as I said before, writing kind of SQL queries and having that compiled onto Spark. But maybe even more important, it gives Spark a notion of schemas inside of someone's data sets. And that allows a bunch of really cool things. One is that allows us to do things like columnar storage, columnar in-memory storage, where we can exploit the fact that we know this data has a schema and do much more efficient storage and processing. The main kind of roadmap items for Spark SQL are the following. One is optimization. So it's fairly well understood how to optimize relational query processing. There's a bunch of tricks that we hope to put into Spark SQL, things like code generation, understanding when you should do certain types of joins. And we have a kind of Scala cool hacker way of doing these things, but it's likely that we'll add these in the next few releases. They're pretty well understood techniques. Other things that are interesting, because of the way Spark SQL has moved forward, we're no longer deeply coupled into the Hive execution engine. So we actually have the opportunity now to extend the SQL dialect and move beyond HQL, which we will still support, into potentially other types of SQL towards something more like SQL 92. And the last thing I'll mention, which I think is actually the coolest of all of these, is that having this notion of typed data sets in Spark is going to let us integrate into new systems in a way that we couldn't do before. So Spark has always supported reading and writing data from Hadoop, the Hadoop data input APIs. And that's worked well, but it's a fairly clunky process to get that set up. And Spark cannot sort of continue to internalize the types of the data once the user has gotten it out of Hadoop, so we can't do these fancy optimizations. But with Spark SQL, this allows us to have much, much nicer integration with third-party data stores. We actually already launched with the initial version of Spark SQL support for reading and writing from a Hive metastore or Parquet files. Reading JSON data is hot on the heels of that. But in the future, I'm expecting this to allow for really nice integration with things like NoSQL data stores. Cassandra and DataStax are already working on this. That's kind of the lead on this effort. And also with things like traditional databases. So you heard the SAP talk this morning. This is something where we really want Spark to work well with these sort of traditional RDBMS systems. And what Spark SQL gives us is a way to have really sort of high performance data sharing with these systems. So a natural question is, okay, there was this project called Shark, and what's going on with that? How is that evolving in the Spark ecosystem? To give a little bit of background, Shark is a project that took it essentially was a fork of Apache Hive that rewrote a lot of the internals to compile onto Spark. And for the last few versions of Spark, we've released a version of Shark alongside of Spark. So you might wonder, okay, where's the version of Shark for Spark 1.0? And especially adding potentially to the confusion, we have now this kind of built-in, more tightly integrated SQL support inside of Spark. So what's going on with that? So we took a look around, and what we've realized is that the only really missing piece of the APIs exposed by Shark in Spark SQL is this JDBC ODBC server, which is a kind of query server that people can run. And we've decided to just merge that into Spark, starting in Spark 1.1. That's the next version that's coming out. So this will provide a seamless upgrade path for existing Shark users, and it significantly decreases the complexity of having two different projects. Most of our efforts are going towards Spark SQL now, and so that's what we want people to gravitate towards. But in the meantime, because that requires users to wait a few months, and maybe people want to get started right now, we're going to release a preview of Spark 1.01 with this JDBC component. It's actually a fairly small, lightweight component, so that users can start playing with this now who are existing Shark users that want to just directly upgrade. And that's something we announced yesterday, and it's going to get merged into the upstream fairly soon. So the kind of other very active sub-project, and actually Shangri Meng, who's the head of this project, came to me today with the most recent count of committers, and it was questionable whether this might actually be the most active now, but I'll let those guys fight it out. So this is the second most active. It's the machine learning library. So MLlib in Spark 1.0 had about 15 algorithms, and in 1.1, we're expecting roughly to double that. So it's a really high period of growth. What is coming? Well, one thing we announced yesterday is that we're going to have in 1.1 some of the more traditional descriptive statistic algorithms. So these are things like if you use R or MATLAB or SciPy, you might use sort of very standard techniques to look at new data sets, do things like correlation, sampling, chi-squared tests, this kind of stuff. So a bunch of that's coming in 1.1. But also, we'll continue to add new types of learning algorithms. There's a long list of sort of three-letter acronyms here, and you can look at Shangri's talk on the MLlib roadmap for more details about that. Another thing that we're announcing at the summit here, for those of you who aren't familiar, there's a project called SparkR. It's not a part of Spark currently. It's more of an alpha project. It was a research project out of UC Berkeley. And the goal of SparkR is to give people who are comfortable writing programs in the R programming language direct access to the native Spark API. That's a very popular language for data scientists. So this week, Alteryx, along with Databricks, announced a partnership to take SparkR and really make it production ready. There's a couple things on the roadmap there. One is integrating better with the built-in statistical algorithms we have now in MLlib. Another is kind of consolidating better the data frame and RDD data models. So this is work that's going to happen kind of over the next 6 to 12 months. It's one of the more long-term roadmap items, but it's super exciting, and we were happy to announce it at the summit here. Okay, so that's the libraries, and there's tons of other stuff going on in the graph and streaming libraries as well. Don't have time to talk about it today. But what's going on in SparkCore, where I hang out? So one way to think about this is to look at trends that are going on in the broader ecosystem. There's kind of two trends that we pay a lot of attention to these days. One is that on the hardware side, memory prices are continuing to fall. The decline in price of memory was one of the whole reasons why Spark was kind of created in the first place. But it's really common for us to see huge machines with huge amounts of memory, like 300 gigabytes plus. And maybe more interesting, SSDs are kind of here to stay. And these solid state devices have some storage properties that might be very attractive for Spark jobs. On the software side, sort of related to the memory point, we've seen an increase in these kind of shared memory platforms. One is Tachyon, that's a product out of UC Berkeley that we're obviously really familiar with. But also in the Hadoop ecosystem, there's some efforts to provide kind of a global shared memory. These have some implications for Spark, and so I'm going to talk a little bit about how we're addressing these in the next slide. So let me just digress for a moment. One of the big things we're working on in SparkCore is having better pluggable APIs. And this actually helps with the trends that I was talking about before, but I want to talk about this in isolation for a second. If you look at very successful open source platforms that get tons and tons of developer interest, one way that we can enable innovation is by offering really clear internal APIs and points of extension. So one good example here is the Linux virtual file system interface. This is way back in the day, but the Linux community virtualized their file system. They created like nice internal points of integration for people to come in and try out new file systems, and that created a huge increase in kind of activity and innovation in that space. And now, like all of the file systems on Linux go through that API. So similarly in Spark, we're looking at taking two of the major internal components and making them pluggable, defining clear APIs so that people in the community can extend them. And those two are the internal storage API. So this is really relevant for all of the trends I just talked about. We'd like to support things like hierarchical storage using SSDs, the ability to store intermediate data sets in these kind of shared memory systems. And the way to do that in a kind of an elegant way is to abstract the APIs internally and allow for different implementations. We're also abstracting our shuffle API. For those who don't know, the shuffle is kind of a really important internal component of execution in Spark. And we'd like to support different types of shuffles, one that maybe looks more like the Hadoop shuffle, it's sort-based, and other types of things like pipeline shuffles. This is a big performance win for certain types of workloads. And by generalizing the API, we can allow people in the community to come in and help design different types of shuffles in a way that's pluggable. So I'm going to give a quick timeline for where these things fall. I don't even think everything in the talk made it on this timeline. But the immediate thing that's coming out very soon is this JSON support in Spark SQL. Many of the things I talked about will end up in the 1.1 release. The asterisk on short-based shuffle means that it might get bumped into the 1.2 release. We need to see how quickly it progresses. And then other things are a little bit further out, like the refactoring the storage support and having SparkR work kind of production ready. So this was just a whirlwind talk about some of the things we're working on, but I only really scratched the surface here. Just to flash a couple other interesting things. In Spark Streaming, we're working on kind of integration with new data sources and tighter integration with Flume. That's something Cloudera is helping with. The graph library is undergoing a bunch of changes this summer with optimizations and sort of getting towards stable APIs for that component. And in Spark Core, there's many, many things that are going on. Some particularly notable things are looking at how we can better work with Yarn, and particularly around elastic scaling of a Spark job, and also adding kind of many more usability features, things like metrics, counters, things that people want when they're kind of writing real production Spark applications. I'll also add, this is a community-driven project, and I can get up here and say what I think we're going to work on, but at the end of the day, it's influenced by the developers. Like, we exist to serve the developers, so as new demands come up from the community and new contributions come, we address those. So I can't even really promise, exactly what we'll work on, because it's going to be a bottom-up thing, like any, I think, good open source project is. So I'm just going to wrap up here. What are we expecting for the next year? Well, the one thing I can promise is that the project is going to continue to grow. And we've kind of built the infrastructure of the project in a way that I think allows for a lot of growth in the future, which is really exciting. We're focusing heavily on the libraries. We think this is really, we're betting the future of Spark, essentially, on these libraries. And on the core, it's a lot about kind of bringing the internals into a state where we think we can support many years of innovation on them. The release process and cadence we've come up with, we hope users like. We really went through a lot of efforts to make this work well for our users. So that's something we're definitely super excited about. So yeah, that's it. I'll just quickly end by saying, if you're interested in learning more about Spark and the development, sign up on the Spark dev list. It's an open source community. We talk publicly about all our development, and so you can always find out about stuff there. Okay, thanks very much. I'll be around all day.
Can you bring up a browser? Is that easy?
Yep. What are you looking for?
Spark Summit. Just wanted to announce that we have started planning. Oh man. Do I make it smaller?
I got it.
A better version of Linux for projecting.
Oh, it's not up there.
Can you put, yeah. So we've started planning the next Spark Summit, which will be in New York. Spark Summit East, early 2015. Probably won't be as big as the Spark Summit, which is the one that stays on this coast. But we are super excited to expand west, east, and then eventually come back around. And also, we're excited about the community growth that we've seen, not just in New York, but with meetups that are springing up everywhere, from Canada to London to India. So sign up here for more information to be notified when we have more details. And you are free to go to the coffee break. We will see you back here at 10:20 for talks from folks at Jawbone, MapR, and my favorite speaker from previous summits, second to Patrick, about neuroscience with Spark.